Today, we will be solving rational inequalities. But first, we will review really quickly how to solve quadratic inequalities on the next 4 slides. When you solve a quadratic inequality, take note that the signs change only at the zeros, and our zeros are our critical numbers, and we're going to use test intervals. That means we will have to create a number line. So how do we solve a quadratic inequality? With this quadratic inequality, we want to factor or use quadratic formula. It's always easier to factor. Once we factor, then we set each factor equal to 0 and we solve. And so we get x equals -2 or x equals 3. Those are our critical numbers. Now we will set up a real number line and we will take note of where our critical numbers are. And now we have also set up intervals. We have an interval before -2 and we're going to test -3. We have an interval between -2 and 3 and we're going to test out 0. And then we have an interval to the right of 3 and we're going to test out 5. So what we're going to do is plug those values in or substitute those values into our quadratic inequality to see which regions will be true. And so when we do that, we see that the region that is true is the region in between -2 and 3. Now we need to test the critical value of -2 and the critical value of 3. When we test the critical value of -2, we see that it is not a true solution, so we use a parentheses. And when we test 3, we see that we get a false solution, so we have to use a parentheses to show that -2 and 3 are not a part of the solution. So our solution has been graphed on the real number line, and then we write the solution in interval notation as well. Now we will move to rational inequalities. With rational inequalities, our signs change at the zeros, which is the numerator, and at undefined values, which are found in the denominator. So our zeros and undefined values are our critical numbers, and we're also going to use test intervals. So how do we solve rational inequalities? First, we put the inequality into standard form. That means move all terms to the same side. Then we add or subtract our fractions by getting a common denominator. Then we will set the numerator and the denominator equal to 0 so that we can solve to get our critical values. We will then test to see which intervals are solutions, and then we will graph on a real number line. And also we will write our solution using interval notation. So our first example is 3x minus 5 over x minus 5 is greater than or equal to 4. So first we're going to put that into standard form. And in standard form it will look like this. 3x minus 5 over x minus 5 minus 4 is greater than or equal to 0. Now we need to add the fraction over here. And to do that, we need to get a common denominator, and our common denominator is x minus 5. So that means we need to figure out what must we multiply the first fraction by, and that will be 1 over 1. What must we multiply the second fraction by? That would be x over 5 over x minus 5. Now we will have a common denominator, and we need to simplify that numerator. To simplify that numerator, the first thing that we need to do is use distributive property. And when we do that, this is what we will get. So the next thing we need to do in the numerator is to combine our like terms. And when we do that, this is what we get. So we've added the fraction, and we have -x plus 15 over x minus 5 is greater than or equal to 0. Now, what we need to do is get our critical numbers by using the numerator and the denominator. So we will set both the numerator and the denominator equal to 0 and solve. So our critical numbers are 15 and 5. Now, when we put 15 and 5 on the real number line, we will then test. So when we choose a point from this region and plug it into our inequality, we find out that we get a false solution. When we pick a value from this region and substitute it in our inequality, we get a true solution. When we pick a value from this region and substitute it into our inequality, we get a false solution. So now the true solution we shade, and then we must test our critical numbers as well. When we test the 5, we get a false solution, so we have a parentheses. When we test the 15, we get a true solution, so we use a bracket. So this is our solution graph, and our solution in interval notation is this. From 5 to 15, not including the 5, but including the 15. All real numbers from 5 to 15, but not including the 5. Now, in this rational inequality, I want you to try this one. Notice that it is already in standard form. Also, you do not even have to add or subtract any fractions. So, what is left for you to do? Well, all you have to do is find the zeros in the numerator and the undefined values in the denominator. So, pause your video and then work out this rational inequality. Then start up the video to see how well you did. So, how did you do? Well, if we look at this solution, I expanded the numerator, I factored my denominator, then I set the factor in the numerator equal to 0 and my factors in the denominator equal to 0 and solved. Those were my critical values, so I placed them on the real number line. Then I picked a value in this region, picked -4, substituted into the original problem, and found out that it was false. I picked a value in the region between -3 and -1, substituted it in, and found that it was true. Picked the value in this region from -1 to 1, substituted it in, and found out that it was true as well. Then I tested my critical values to see if I needed brackets or parentheses. And so, of course, then I have my solution, and I graphed it, and I also wrote the solution using interval notation. As always, if you have any questions, please record them and we'll get them answered during class.